looking at factoring trinomials when the a value isn't 1 through a method called the product sum shortcut. So looking at this polynomial, again, we're dealing with trinomials where the a value, in this case, is 3, right, the coefficient on the x squared term. My b value is -4, the coefficient on the x term. And my c value is also -4. So we're going to start this off in a really similar way that we deal with when the a value is 1, and that's what we call our product sum table. We also use this method in decomposition, so you may have seen this before. We are going to ask ourselves, what are two numbers that add to our b value and simultaneously multiply to the product of a times c, right? Because we have that coefficient out front, we want to make sure it's included in this table. So in our specific scenario, we're saying what are two numbers that add to -4, right? That b value in the middle. And what are two numbers that multiply, in this case, to -12, right? That -4 coming from that b value, and then that -12 coming from the product of the 3 out front and the -4 at the end, right? Our a times c. So when going through these tables, I would always recommend starting with the product. It's a lot easier to find products than terms that add. And so when I'm thinking about the number 12, I can think of 4 times 3. And regardless of the signs we put on there, that is never going to give us a 4. So I move on. I can think of 12 times 1. Again, regardless of the signs, that's either going to give us some form of 11 or 13. So looking at the last option, a 6 and a 2. Well, because I'm multiplying to a negative product, I need to have one term negative and one term positive. If I make my 6 negative and my 2 positive, -6 plus 2 gives me -4. And -6 times +2 gives me -12. So these are the numbers we're going to work with. So what I'm going to do is I'm going to start this off looking really, really similar to what we usually do. I'm just going to get rid of my factors here. I'm going to create a factored trinomial, 2 binomial factors, and I'm going to start by just tossing these numbers in there. I'm going to do an x minus 6. I'm going to do an x plus 2. Note that this is not equivalent to what we started with, right? If I was to expand this out, I would be getting an x squared instead of a 3x squared. I would have minus 4x in the middle, but then I'd get a -12 instead of a -4. Right? We found these numbers by making that a times c value bigger. So now we need to undo that fact. I multiplied by 3, right? I did -4 times 3 to make this number here. Right? This is 3 times bigger than it should be, which means that both of my constants are also 3 times bigger than they should be. So I'm then going to go in and I'm going to divide just the constants. I'm not going to worry about the x's. I'm going to divide those by 3. They might turn into nice numbers, right? Nice integers or whole numbers. I'm going to get a -2 in that first bracket. However, in my second bracket, I have a fraction, and we really prefer to write our factors as what we call integral factors, meaning that all of the coefficients, all of the terms are integers, right? No fractions. It helps us refer to different aspects of the actual polynomial a bit better. So how do we get rid of fractions? Well, if I multiply by the denominator, I can get rid of that fraction, right? If I multiply the top, if I make the top 3 times bigger, I don't need to express that denominator anymore. So that's what I'm going to do with this second bracket here. I'm going to take this whole bracket and just this second one, I'm going to leave the first one alone, and I'm going to multiply by 3 in the sense that I'm just making everything a little bit bigger, right, to move some things around. So I keep my x minus 2. The goal of this, and I'm going to start with the second term first, just so we can see. When I do something like 2/3 times 3, right? That's essentially giving us a common factor top and bottom. That means my second term here is just going to turn into a positive 2. But I can't just do that to one term of this bracket, of this factor, so I'm going to make the x 3 times bigger as well. This is our final factored form. Remember, we can always verify this by expanding back out. I can do x times 2, and that's going to give me the 3x squared that I intended for. I'm going to do an x times 2. I get a 2x. I'm going to do a negative 2 times 3x. I get a negative 6x. And I'm going to negative 2 times 2. I get a negative 4. When I combine those like terms in the middle, those x terms, I get a 3x squared minus 4x minus 4, just like I started with. Right, so it starts really similar to, it's kind of a combination between decomposition and our usual product sum. We just have to make sure we're including that extra factor on the end. We also have a very important caveat or extra thing we have to keep in mind with this, and we'll look at an example involving that. So let's look at another example. I have 4x squared plus 22x plus 24. And the same thing is true here, right? I have that a value that isn't 1. I'm going to need to use some other method of factoring than I'm used to. Here, however, we have one very important thing we need to worry about. These 3 terms have a greatest common factor. I need to make sure, if I want the product sum shortcut method to work properly, because I'm multiplying by values and then dividing them out later, I need to make sure that I worry about any greatest common factors first, before I do anything else. I'm actually going to get incorrect factors if I don't deal with that greatest common factor before proceeding. So again, we ask ourselves, and this is how we should start every factoring question. It's good practice to work with that GCF first. I need to say, what do 4x squared, 22x, and 24 all have in common? Well, they're all divisible by 2. So I'm going to factor out a 2, right? Meaning that I'm just dividing out a 2 and expressing it as a product instead, right? Pull it out of there, get it out because they all share it, but keep it written at the front because it's still part of this expression, right? I'm going to get a 2x squared plus 11x plus 12. So I pulled out my common factor. I'm still left with an a value more than 1, so I still have to worry about factoring in an alternate method. But at least I've pulled out a common factor. At least the numbers are easier to deal with, and now I'm allowed to use product sum shortcut. So a reminder, we're going to start it the same way. I'm going to make my product sum table. They need to add to my b value. Now my b value is 11. I'm worrying about only this trinomial here inside the brackets when I'm talking about a, b, and c. So I need to add to 11. I need to make sure I multiply to 24. And again, that's coming from the idea that I have to figure out what a times c is. I know it's coincidentally the same as it was before, right, as it was up top, but that just happens to be a coincidence in this case. So we start to think of some numbers. We think of some factors of 24, right, 12 and 2, but that's not going to get us 11. We have 6 and 4, but that's not going to get us 11. And we have 8 and 3, and there we are. 8 plus 3 is 11. 8 times 3 is 24. So again, I start this off as if I'm just doing regular product sum. I just throw my variables and my new values I've found right into some brackets. And I'm going to make sure that 2 stays out front. It's still a factor, right? It's still part of this expression. So I don't want to lose it. Now I say, well, I actually made these numbers twice as big, right? I found a product of 24 instead of 12. So I'm going to undo that here. So again, sometimes one of your brackets will be nice. Sometimes neither of them are going to be nice integers, and that's okay. We'll just do the same process. When I have my one factor with a fraction, I'm multiplying by that denominator. Essentially, the result is the denominator of the second term kind of just pops up as the coefficient of the first term instead. So my first bracket stays the same, that factor of 2 stays the same, and then I end up with a 2x plus 3. So factoring by product sum shortcut is a really good step-by-step method for factoring that a value of not 1. However, just warn yourself, keep in mind you need to make sure you're always checking for that greatest common factor first if you want to be using this method.